Hello. In this short video I'm going to introduce the subject of potential dividers. Almost certainly the most important circuit that you'll come across, and one that there is a special set of questions in the Circuit Theory app all about. First of all, what is a potential divider? Well, the idea is that it's a circuit which divides a potential by a fixed amount, hence the name. If I had a point in a circuit there at a certain potential, let's call it V volts, and if I connect that through two resistors in series down to ground, then the output of a potential divider would be this point in the circuit here, halfway up. Well, not necessarily halfway in terms of resistance or voltage, but halfway in terms of how I've drawn it here. Let's suppose that this resistor here has a value of R1 and this resistor here has a value of R2. Then we know that the total resistance in the circuit between V and ground here is R1 plus R2. So the current that flows along here, I, that must be equal to V divided by R1 plus R2, just the total current flowing in this system. If I then apply Ohm's law to this resistor here, R2, and say what is the voltage across R2, then that is V equals I R2. I is V over R1 plus R2, therefore I'll call this V out. Should have done that to avoid confusion. Then V out is V, I could call it V in, is V in over R1 plus R2, that's just the current flowing, times the resistance R2. So it's Ohm's law. V across this resistor is the current flowing through this resistor, which is V in over R1 plus R2, times the resistance itself, which is R2. The way that's more usually written is V out equals V in times R2 over R1 plus R2. Right, let's see some examples of this. Here is a circuit which currently has no volts at all at the top, and therefore no current flowing, and therefore no voltage across this resistor, so its output is 0. But if I put 1 volt across the top, then a total current of 250 microamps would flow, and that's because the total current in this network is 4K. And if I take 1 volt and divide it by 4,000 ohms, I would get the 250 microamps, which is flowing down there. The voltage across this resistor here is then just calculated from the current flowing through the resistor times the value of the resistance itself, which is 500 milli, and as we see, that is the voltage across this resistor. Okay, supposing we change this resistor so it was 6K. Now, the total resistance between the 1 volt here and ground is 6 plus A, that's 8K, so 125 microamps flowing. Fine. And the output voltage would be 125 microamps times the 2K, 250 milli. And that's the output voltage that we see here. Now supposing we had 10 volts, everything would increase by a factor of 10, would go up to 2.5 volts. It's called a potential divider because whatever the voltage is at the top, the output here, in this case, is always 1/4 of the input voltage here. We go back to here, write this formula in a slightly different way. We could see that V out divided by V in was R2 over R1 plus R2. So the ratio of V out to V in is constant, always R2 over R1 plus R2. And what we're seeing here, the ratio of R1, which is sort of R2 rather, which is 2K to R1 plus R2 is 250 milli, or 1/4, because that's what 1/4 is, a quarter, 0.25. And whatever voltage we put here, we'll get 1/4 of it there. Minus 4 volts, 1 volt output. Minus 8 volts, minus 2 volts outputs, and so on. Now, that's basic theory, and all you need to know to solve some of the simpler questions in the potential dividers section. In this case, what reading would the voltmeter show? Okay, well the current would be 9 volts divided by the total resistance in the circuit, which is 2K. Once I've got the current, I just multiply the current by that resistor, which is 1K, and I get 4.5 volts correct. Great. How about here? Well, might look a little strange. It's drawn in a different way, but exactly the same principle applies. 5 volts divided by total resistance in the circuit. In this case, it's 220. 200 plus 20. That's the current. The current flowing through a 20 ohm resistor would create that voltage across that resistor. Good old Ohm's law again. Current times resistance gives voltage. 450 millivolts. We've done one of those before. It's exactly the same circuit, it's just drawn a different way. 7 divided by 300 times 100, 2.33. That's the current flowing in the circuit. The current of that much flowing through a resistor of 100 ohms gives you the voltage afterwards. V equals IR. Going up to level 1, they get slightly trickier because sometimes you have to work out the source voltage, and now you have to do a bit of algebra. How do you do that? Well, actually, let's write down the question first. We've got a voltage here, which is an unknown voltage flowing through a 10K resistor and then a 5K1 resistor. And the voltage at this point here in the circuit is 236 millivolts. Okay, well if I know that, then I can work out what the current must be. Because the current down here, flowing through that resistor, must be 236 millivolts divided by 5K1. That's voltage divided by resistance, that gives me current. So I know the current in my circuit is 46.3 microamps. Okay, if I've got 46.3 microamps flowing in the circuit, then if I multiply that by the total resistance in the circuit, that must give me the voltage at that point there. 699, it's probably 0.7. Yeah, great. And again, same principles, I've just applied them in a slightly different order. I've worked out the current that must be flowing because I know the voltage across this resistor and I know the value of this resistor. And if I know the current that must be flowing and I know the total resistance between this point here and that point here is 15.1K, then I must be able to work out that voltage. Just Ohm's law again. Voltage is current times resistance. And there's a few that will look slightly unfamiliar because the circuit is drawn in slightly different ways to confuse you, but this one is in fact a very straightforward one. 10 millivolts divided by the total resistance, which would be 3 meg 7 multiplied by 1 meg, 2.7 millivolts, etc. That should get you started with the potential divider equations.